All right, so let's start implementing systems. Now, when we're looking at our game screen, ideally we want to try to have everything operating in Ashley as possible. So we might create the viewports and the engine and the camera, but we're going to have almost everything else created in there. So we could create the world, and then we just pass into the system that we need. So this will get moved out. Our world step that we did, that's going to get moved out. Our Box 2D renderer, we're going to have that actually as a system. So all that this rendering is doing is, other than buffering the screen, it's just going to update the engine, and that's pretty much it. We could do a camera system too. All right, so let's look at systems. So I already have a package created for systems. The first one, let's do a physics system. So let's go new. And the physics system is really going to only be used for dealing with my Box 2D entities, giving that position back to our transform, and that's about it. So there's a number of different systems that we can use. You can have interval systems. Let me open it up. Ashley ACS, so you guys can see it. There's a number of different systems that we can use, and all of them kind of do a little bit different. Okay, we have an iterating system, an interval system, an interval iterating system, and a sorted iterating system. For rendering, we will probably want the sorted iterating system so that we can set some type of parameters so we can have stuff draw specifically in order. Interval and interval iterating and interval systems, those you set how often you want it to update, and that system will only run that specific time period. An iterating system is, instead of just doing a normal system, it will allow you to basically look at every entity that meets your parameters. Okay, so we're going to have to build some component mappers. You could do it like this, but I feel that that starts getting redundant, so we will actually create a separate class that will hold all of our mappers. It will actually act faster. And then when you create your system, what it's doing is it's calling that iterating system, and it's pulling every entity that has these component, the position class or velocity class. It will go through, and anything that has both of those, it will add it into like a list of what it needs to do for doing the system. And then you have where you just process the entity. So you're processing the entity could be, because it's running through every single entity, that you are just updating some piece of information. So if we look at just the actual, that's not what I wanted. If we just look at the normal entity system, it gives a little bit more framework. Entity systems. Okay, so we have a number of methods that we can use for it. When you're adding something to, so we can remove systems, we can pause systems, we can add listeners for when an entity is removed or added. This is actually what I wanted you guys to see. So the family is basically the list that it's holding, and you can have where you're doing everything that has that component. You can do stuff where you want it to do everything that doesn't have that component, and basically really build something specific for your class. You got to be very careful though when you're trying to do these systems, because if you're trying to call something that doesn't have one of those pieces, it will end up failing in your code. So not all systems have to run for every entity, but you can't, if you create, let's say, an enemy that does not have a projectile component to it, but in that system that you're calling all of those entities, and you're not factoring out or filtering out the ones that don't have a projectile, it's going to fail as soon as you're trying to change some data for a projectile component that enemy doesn't actually own. So we got to be kind of careful in how we're creating this, but this is where we start adding functionality. So let's just do physics system. And we know that the superclass is going to be an iterating system. Bam. Okay. Now we want to implement methods. Okay. Let me look at my system just for reference. Okay. Shouldn't be any issue. All right, so basically what we want this one to do is we want it to run our world, and we want it to actually have, we can control how often it's updating the world step. If you lock this in, then you can make it so it's not using more processing power to try to process faster. You can kind of control speed of movement. So this would be helpful for us to do this. So let's do we're going to do a private static, and we're going to actually make it a final because we don't want it to change. So let's do, we'll call it max time step. Okay, and oops. And this, if we were doing, say, 1/60f, that would be 60 frames a second. 1/45f would be 45 frames a second. I say let's just lock it to 1/30. Again, you know, if you want it smoother, bump it up. As long as you are sure that everything can process it, it wouldn't be a problem. And let's do a private. Why do you know what? I don't want this to be static. So when I create my system, I want to set it, and I'm only going to have one physics system, so I don't need to have it static. Private float, this one will change, and let's call it accumulator. Accumulator, okay, and we'll do that as 0f. We know we're going to have to hold the world in here, so world, put that in, and we know that we're going to have an array of entities. That we'll just call bodies Q. Don't feel like you have to design stuff exactly like mine. Once you start getting some stuff running, I encourage you guys to change things. I've researched a lot. I didn't come up with all this code on my own. It's more of looking and finding how people are doing things and then customizing it for my own purposes to make things work how I want it to work. Okay, so when we do a system, we also have to do a constructor for that system for when we create it. We can choose if we want to just put the family in, or if we want to have a priority of which system we want to run before another system, starting low and working up. So if we need to change that later, we could do that. We know that when we're going to create a system, we're going to have to pass in that world for controlling all those entities. Okay, we're not passing in the family. We're going to create that. So let's do another helper right now, and we're going to, where is it? We're going to map to everything using a static helper. So let's do a new, let's just call it mappers. From all the documentation that I found, this is actually a faster way of doing it. It's basically a one-for-one when you want to call it. But everything's going to be public static final. So public static final, and then we're going component mapper, and we have to pass in what we want it to map to. So I'm saying let's do body, because that's what we got first, body component, and then I give it a name, body component. So this mapper is helping us speed it up. So component mapper, and then you got to go .get for, and then it's body component .class. So now we have basically an address to map to that body component for pretty much any entity. It's going to be able to find it easily. So let me create for the rest of them. Public static final collision. Collision component. Oops. Component mapper. There we go. Collision component. I like to write it all out so that I can easily reference. Class. Okay. Public static final component mapper. Did body component player. Player component.class. Public static final component mapper state component. So we have a workflow now where we know where to add. We got to add a method whenever we are creating a component in our entity manager. We create a component, create that method in our entity manager so we can make it easier to add. And then we're going to go to here in our mappers and add an entry. State component dot class. Static final component mapper. Component, oops, dot class, public static final, component mapper, last one, type component. Okay. So now we got a mapper for every one of our components. We got 6, 1, 2, 3, 4, 5, 6. These are our, so that we can get to them much faster. Instead of putting them in each system that we're going to be writing, we can just call to them, so we don't have to create them and initialize them here. But we will want to create an instance of them so that we can use them. But let me look at one of my systems. Yep, okay. So here our family, or our list of things that we need to have, and here I'm going to do family.all because I need everything that has a let's do everything that has a I guess let's just do the body right now. Everything that has the body component. So body component dot class, and then dot get. Everything that has a body component is going to be working with my physics system. So then when I get to the process entity method, this is running every entity through it. Okay, so for this, then I need, I gotta do my bodies queue. Bodies queue equals new array, and it's going to be an entity array. Okay, so as I'm processing all of my bodies through, this way I'm just, and we can do it a number of different ways, but since I want them all to basically, if they have a body, I want them to get stepped with the world basically all at once. So as I'm processing the entity, all I want it to do is just bodies queue dot add and just add the entity. That's all I really want it to do. Okay, and then I have different methods that I can use for my physics system. So if we look at what systems we can use, we have added to engine, remove from engine, update, which is going through the entities, and we have other methods that we can do. So we can process individual entities. So the physics system, we're going to use that update. So let's implement this. And let's see. Our physics system, when we are creating, we want to basically step our world. Actually, all right, let's just play around with this. I'm going to actually add the transform component also. Class. I might change this later. Okay, so we have all entities that have a body component and have a transform component as part of it. I want to run the update, which this, let's go let's call it frame time. And I want to do the minimum between delta time, delta time is kind of the change between when it has rendered. It's done a render call, and let's say 0.25 f. We'll just lock that if delta time has been like a really long time, at a minimum, I'm going to be changing frames approximately once every second, or every quarter of a second. If delta time is much lower than it, meaning that I need to change my frames because stuff has happened, then I want to use my delta time more often. Okay, so then I'm going to use that accumulator, and I'm going to add to it whatever that frame time was. So if the accumulator is greater than or equal to my max time step, then I want to step my world dot step, and I'm going to step it based off of that max time, and then we're using 6 and 2. So before we were doing delta time, which was basically just running as fast as it could and was doing stuff. Now we can kind of lock it into a certain one, and then I'm going to want to subtract my accumulator off of it, or subtract the max time step from my accumulator. So anything that's left over, it's going to help make it update faster if it needs to. And then inside this if statement, I could go through all the bodies in my bodies queue that's already been added, and then I can take the inputs from the body and take that data and update the transform component. So let's do a an enhanced for loop, and we know each one's going to be an entity. We're doing it from the bodies queue. So our transform component is going to be equal to, now this is where I'm statically getting from that helpers class the mappers. So mappers dot get, why do you not like it? Oh, excuse me. Mappers dot transform component dot get entity. So I'm getting the transform component from the entity that's passed in here, and it's like a straight one-to-one. It's super fast. And then we need to do for body component too. So body component equals mappers body component dot get entity. Okay. So vector vector 2 to position is equal to that body component dot get body dot get position. Okay, so that's giving us vector 2, and then we can use that to update our transform. So transform component dot set position. Actually, you know what? Let's do. What if I only want to do X and Y? Okay, so let's go back into our transform component. If we're having it hold X, Y, and Z, but we need to update it with just the, we're going to overload the set position. Set position, it's going to take a vector 2. This dot position dot x is equal to position dot x. This dot position dot y is equal to position dot y. Okay. All right, so now go back into my system. Transform component dot set position. Now I can pass in a vector 2, which is going to be that position that I just did. Position. That looks good. If we need to change rotation, so transform component dot set rotation. And we can do this for body component dot get body dot get angle. Multiply that by radian. We need to get this in from radians to degrees. So math utils dot radians. Where are you? Bam. Okay. All right, so we run through every entity, we pull their transform component, the body component, we get the position of the body, set the transform components x and y to that, we leave the z how we want it. The transform components set rotation, we take that, we put it in there. And once we finish all of that, then we need to remove or empty the bodies. Let's clear them all out of that list. And that system is basically done. So now we can go in and in our main game screen, we could set up that system. So actually, let's add private. What do I call them? Systems. Oh, well, that makes sense. Okay, so we just did physics system. Physics system. All right, so we add that. We create the engine. Let's just do public. I'm going to just kind of create a method for holding all my systems in one place, so it's going to be easy to see. Init Ashley systems. Okay. I don't need anything. Okay, so then my systems, physics system equals new physics system, and I have to pass in the world, which I don't have yet. Okay, so now we got world, and let's change that gravitational forces. We don't need that there. We can put it in our figures. Types world gravity public static final vector 2 gravitational forces equals let's get confused how to create a vector 2. Gravitational forces equals, let's just create a new vector 2 and we want okay, so then in my main game screen, I am just pulling this from figures dot gravitational forces. Okay, so I got my world. I'm passing it into that Ashley system, the physics system. And the last piece that we do after we add a system, okay, so we create it, and now we got to take the engine, we got to add that system. Physics system, that's it. Okay, now the order of when we add those systems are the order that they update unless we change that priority. So this system, this is completely done. We have our physics system. What's the error? MathMin delta time 0.25f. Okay. We have our physics system, and all it's doing is it's just setting up a relationship between our body component and our transform component. It's processing all entities that have those two components together. So if I did, like what I was saying, if I was just pulling body components and I didn't have this transform component on here, and then I'm trying to get the mapping for it, that's where it can fail if I have an entity that didn't have that piece. And then in our main game screen, we set up, we created that system, passed in its needed information, added it to the engine, and then all we really have to do in our render is, let me comment out this. We're running this, and then we are just doing engine dot update, and we pass in that delta time. That's it. So this is already doing our world step. Don't need that anymore. That should be working, but we can't really test it completely until we get down to that point. So that's one system. We'll work on a physics debug system and then a movement system afterwards.